Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode and try to see the approach. So this is the extension of yesterday's problem, maximize the number of target nodes after connecting trees. There exist two undirected trees with n and m nodes labeled from 0 to n minus 1 and 0 to m minus 1. And you are also given the two edges list. The edges of I contains the edge from A to AI to BI, and uh, U is a target node to V if the number of edges on the path from U to V is even. Okay. And note a node is always target to itself because 0 is an even number, because there is zero edges from itself to itself. And return an array of n integers answer, where answer I is the maximum possible number of nodes that are target to node I of the first tree if you had to connect one node from the first tree to the second tree. So you are given two trees, right? Similar to the previous problem. So uh, let's try to see the example of this. So we have 5 node tree here. Let's try to see how that example is working. So yeah, we have it. I have this 0 node first, then I have the 1 node, 2, and also 3 and 4. 3 and 4 here. Okay. And I have this also 0, 1, 2, 3, 4. I have 0 here, 1, 2, 3, 4 is there, isn't it? And I have 5, 6 to the top of 4 and 7 here. So I have 5, 6 here and 7. So if you see now, for the answer of 0, so you have to, there are n nodes and m nodes. Your answer vector will have n length for every node. So if you, for 0, if you need to connect to one of the node, which one will it be? So if you connect from this 0 to this 0, you see, if you make a connection here, how many even nodes do you get? So first of all, this is itself an even, because this is a 0 is an even number. If you go from 0 to 1 or 2, you take one hop, but you need 2 hops at least. So in order to reach 3 or 4 from 0, you require 2 hops, and therefore that is even. So this node is even node, this node is even node. And again, from 0 to 0, you will take 1 hop, is wasted there. So all the adjacent nodes of 0 will be another even hop. So all these nodes will also be adjacent, will also be counted as even. Then again, this will take an odd number of hop. Then again, this will also be an odd. So this will not take these two nodes. And then again, these two will be even. So total we get 1, 2, 3, 4, 5, 6, 7, 8. So the first answer of 0 is 8. And you can understand that for every node, there might be the situation that we need to connect with something else to get it even or odd count. Okay. So let's see. Let's try to start the coding. Okay, I will explain you in detail, step by step. So what is the first thing we need to do? First thing we need to find n and m. Okay. So as we have done, so we will traverse through all the edges, traverse through every thing of the edge, and then just return the maximum value and add 1, because here 0 to 4, so the number of nodes is 5. Okay, so n is 5 here. So I have n as 0 initialized, m as 0 initialized. So I will go from 1 to n here, and edges of what I will do is that I will do n equal to max of n edges of I 0. This will be 1, 0 is 1 of I 1. Okay, you find n this way. This will be edges 1 dot size. you traverse through the edges 1.size, and in a similar fashion you can find out m. You can find out m. Okay. You now need to create the adjacency list. So just you can call a function make graph. You first need to initialize the adjacency lists. So you have vector of vectors. You have two vectors. Okay. V1 is at adjacency 1. This is tree 1 and this is tree 2. Okay. You initialize. So one thing you need to take care that you need to increment n and m as I told you, because the maximum value here will be 4, but the number of nodes n is 5. So you get n and m first. You make the adjacency lists. How do you make the graph? You pass the adjacency list 1. You say that I need to fill the value using edges 1 and this n. Okay. Similarly, you can make graph adjacency list of 2 edges 2 and m. Okay. You made both the graph ready. So how to do that? You can write a make graph function. What it will do? It will take an adjacency list. Okay. And it will pass by reference because you need to alter the list itself. It will definitely take a vector. It will definitely take a vector edges of 1 edges, and it will have number of nodes n. Okay. So what it will do? It will traverse through the all the edges in the graph, the order of the edges of size. It will traverse through the edges, and you have u and v. You have two edges u. So edges of I0 is u. Edges of I1 is v. What they will do is adjacency. Will say that adjacent u is v. These are the standard things that we do in graph, as you know it. And adjacency of v is u. Okay. These are the simple which we actually do in every possible graph problem. We make the adjacency list. So we have a tree here. We make the two trees ready. Now ready for the manipulation. Now we should start thinking of the logic that actually what should we do. So if you want to see, every node will be either even or odd. Do you agree? So what do I mean by this? So let's say you have this 0. So if you go through a BFS traversal, as I see, BFS, what you do in BFS, you have a 0, you have some nodes connected to it. These are the first level nodes that you get, and these are the first level nodes. Okay. So just cover this one. First level nodes for k, and then again you go to their neighbors and get the second level nodes and stuff like that. Okay. So definitely, if you consider the initial one as 0 even, then all its neighbor nodes will be odd, and all its again the neighbor of them will be even again. So in this way, you can you can start from any node, you can start the BFS from any node. Let's say you are starting from 0, and you will, for each BFS level, you just flip the parity even odd, okay? And you just count the number of nodes because you want to see the even nodes. So let's say you have an even here. So the even count, let's say you have the even value and you have the odd value. Both are initialized to 0 at first. So you initially you do even equal to 1 because it's 1, right? One node. And then you get two adjacent nodes which are at a distance of 1, which are odd. So odd becomes 2. Now You get 3 and 4, which are again even. So even now becomes 3. Now if you see these 3, how many nodes does this 3 have in even contact? So 3 can reach 4 also in even, always, because it has definitely a common parent. And 4 can also reach 3. And 3 can also reach that 0 because it has reached 3 in even number of hops. So you can say that for nodes, for all the nodes 0, 3, 4, which are at an odd distance, for all such nodes which are at an odd distance from 0, the number of neighbors at an even count, the number of nodes at an even count is the same, which is stored in this even value. Similarly, it will be the for the odd one also. If you consider 1, how many nodes are at an even distance? You will get only 1 and 2 itself. No nodes are at an else no other nodes is at an even distance. So the count of the number of nodes which are at an even distance is always this. Okay. So similarly, you make what you can do. You can similarly do a DP. Okay. Of this tree, and dp of I will store what it will store max number of nodes reachable at distance I, at this even distance, from node I. Okay, you create two dps for the both of these graphs. Okay, so how you will achieve it? It's quite simple. So you need to mark the nodes at first, which are at an even distance, and you need to store the event count for all of this. So as I already explained you, the event count will be same. So you do this thing for both the graphs, and then try to connect them, and see which is the optimal connection. You always need to connect them with the max count. So whichever node will have so for every node we will iterate through this tree and see whichever node in this tree 2, whichever node is having the maximum count. So there can be only two types of count, as I told you, odd or even, as you iterate. So what will be the counts? Let's try to understand this also. So if you consider 0, the even will be first at 1 because it has 0. Then these three nodes are odd to 0. Then again 7 and 4 are there. So you will take 7 and 4, add 2 to this one. Okay. And then do nothing else. Okay. So this even value consists of nodes 0, 4, 7, and it has the number of nodes to be 3. Similarly, this odd value, if we take, the first, it has 2, 3, 1. It has 3 nodes. Then again it has 5 and 6. Then it has 5 nodes total. Okay. And these nodes are 2, 3, 1, 5, 6. Okay. These are the nodes which you are actually having of the same odd count. So this I am telling the DP value of, so if you don't understand still, the DP, I am saying the DP of 0 will be 3 here. DP of 4 will be 3 here. DP of 7 will be 3 here. Okay. Similarly, DP of 2 will be 5. DP of 3 will be 5. DP of 1 will be 5. This is what I am telling you. Okay. So because DP of I stores what? This is the maximum number of node reachable at an even distance from I. So that's what it stores. So what I do at first, since I made a make graph thing, I will again make another function fill DP because we need to do that thing for both of the graphs. So this time we only pass the adjacency list, we pass n, and also we pass a DP1. Okay. So we will make vector in DP of 1 of n, DP2 of m. Okay. So you got this. Again, you will do this adjacency list of 2n dp2, right? Now, what you do, you need to just fill the dp. So you must have the adjacency list. Okay, passed by reference. You must always pass by reference. Uh, then you have the vector dp, which you also need to pass by reference, and you need to alter that. Okay. Yeah. So now what you will know, you need to track the care, you need to take care of the level wise. You are doing level order traversal, so you need to track the level. I am at even level or odd level, you need to check out, right? So initially the level is 0. Now we perform a simple BFS, right? If you don't know BFS, just quickly go and check it out for the simple algorithm and implement it with a queue. So I will start with 0, which is the starting vertex. I can start with any vertex. I'm taking it for 0 for all. And now what I will do, I also need to have a vector visited array. Okay. I need to initialize this visited array of 0 to 1. So this is already visited. And now what I do a BFS traversal with while q not empty. And as I'm tracking the level, as I already told you, to track the level, you use this kind of BFS size. You just increment the size here, and while size minus minus. After this, you just increment level plus plus, okay? Because the level is incrementing. So you have it. And this standard things, I'm just doing it quickly. You just extract the node from queue front. Then you just queue.pop, you just remove the queue, and things which need to do in a general BFS, everything you need to do here. Also, you go through the adjacency list. You go to the adjacency list of the neighbors to find all the neighbors, right? So you go to the adjacent of node. If you find that the current adjacent node, if the adjacent node is not visited, what you do, you make it visited one, definitely, but you also push. You do q.push to that vertex v. Okay. So these are the standard BFS things which I did. And now what you need to do is you need to take care of the level, right? For every level, you need to take care. So what if the level is odd? As I told you, I'm taking care of odd level or even level. So I need two variables, odd count and even count. So I'm just keeping it odd 0. These are the two variables which I'm keeping, odd and even. To track the number of nodes, it tracks the number of nodes. Okay. Tracks number of nodes at an odd and even distance. Tracks number of nodes at an odd and even distance from 0. Okay. So it is just grouping the nodes. So if level is an even number, what you do? You increment the even by a size. Okay. You do understand what is the size? The size is initially the queue has this element 0 only, then 0 will be used, and then the queue will only have 1 and 2. It is, since it is doing level order traversal and size minus minus, so it will exhaust all the elements in the queue first, in why after iterating through this size minus minus loop. So and then it will have 1 and 2, then it will have 3 and 4. So we need to increment the size by that number of counts, right? So the count of 1 and 2 is 2, and count of 3 4. So here the count will be 3 2 3 1 is there. So there are 3 nodes, so I need to increment the count. Else I have an odd thing, so I also need to increment by, or I need to increment the odd value by count this. Okay. Now what you need to do, definitely you need to fill all the DP. What you need to do, you need to fill all the DP of odd to be odd count, odd nodes. But how will you understand which are the odd nodes? So one thing you can do here also, if you find node is odd, initialize the DP is initialized with 0, right? Here the DP is initialized with 0. So if you find the level is odd, what you do, you do DP of node equal to -1. So this acts as a marker for nodes which are at an odd distance. Okay. Okay. Because you need to do dp of odd nodes equal to odd and dp of even nodes equal to even. These things you need to do. So what you do is now simple. You just iterate through the n value. If you see if dp of I you see to be -1, you do dpi equal to odd, else dpi is even. You find the even and odd counts, right? Now you have the dp field ready. Now what you need to do, you find the maximum count for tree 2, which you need to store actually, right? So what will be the maximum count? I know that for dp2 there will be only two values because even and odd. Yeah, but I'm doing this. You can optimize this, but it won't harm much. I'm just doing the max count, comma, this dp2 of I. I'm keeping the max count. This I'm doing to see which is the optimal node which I need to connect to. Okay, which is the optimal node which I need to connect to, because that one will have the maximum number of even or odd nodes. Okay, which is the maximum value which I need to add. So you'll see that for 0 to 0 here, here the maximum count is how much? 5. You see the maximum count for this T2 graph is 5. Okay. If you don't understand, this maximum count for T2 graph, as I showed you here, is 5. And the maximum count for this 0 is 3. Isn't it? So that's why we just do 5 plus 3, because we know the achievable maximum by connecting some nodes is 5 here. So the first will be 5. Similarly, 1 and 2 will be 7, because you know that 1 and 2 there are only 2 nodes. Here odd is 2, and the maximum achievable by connecting is still 5. So you get 7, 7 for these. Then again these will be 8, 8, 8. So that's how the answer is coming. So yeah, you have the max count which you need to add every time. Now all you do is fill the answer and return the value, and we are done with it. So we have the answer, and you need to iterate, and what you do, answer equal to max of answer, not max, sorry, what I'm doing this, answer I is nothing but dp1I plus max count. dp1I says current, you iterate through the current tree and find the maximum node, and also the maximum achievable count from the tree 2, the maximum achievable count from the tree 2, and the current count from dp1, the current tree. Okay, you need to return the answer, and you are done with it. Yeah, so let's try to run the code. Let's check if there is any error. Yeah, so there are some semicolon problems here. Let's try to run it again. Okay, so we do have a runtime error. Let's try to see what is the error. Okay, so if you see, this adjacency will be initialized to m, because we are passing the m value here. Yeah, try to run it now. So that works. Let's try to submit it. So yeah, we have an okay-ish runtime complexity, and yeah, that was all. That was all for this problem. So this was a hard kind of problem, but if you know VFX properly and if you can visualize and understand this odd and even count thing, you can definitely solve it really easily. So that would be all for today. Thank you so much.